Okay, so now we want to go through the actual homework problems, and there were really just two groups of problems, you might say. Problems 2, 3, and 4 both dealt with an example that was in the book, and so this is the data that you're given from a book. From the book, you know how many people have the disease, and you give them the test, right? And you tabulate their results. Okay. And the first thing you want to know is what percentage of individuals in the study were false negatives. The important thing to understand is the negative refers to the test result. The false means that it's incorrect. So we had a negative that was incorrect. So when do we get that? Well, when the person actually has a disease. Okay? So this is going to be the number of people, when you test negative, who don't show, who show that they have the disease. Okay? In other words, it's the percentage of negative tests that were wrong. That's the probability of a false positive, of a false negative. Okay, so in this case, we had 239 negatives. 9 of them were false. And so this is our probability. I computed out the 5 decimal places, rounded to 4, expressed it as a probability, and your final answer is 3.77. Okay? What percentage of individuals in the study tested negative? Well, that's easy. That's just the fraction of people that had negative test results. So we take the total number of people. There were 300. 239 tested negative. Therefore, roughly 79.67% of the individuals had a negative test. Okay, it's the fraction of people that had a negative test. Okay, for what percentage of individuals in the study did the test return an incorrect result? Okay, so we want to count the number of incorrect results and divide it by the total number of people, right? Well, where do we have an incorrect result? Well, we have an incorrect result here, right? They have the disease, and the test says they don't. So there's 9 people here. But these are also incorrect test results, right? These people don't have the disease, but the test says they do. So these two things added are the total number of people that had incorrect test results. So there's 34 of them, 300 people in our study. So when we compute this, we end up getting 11.33%. Okay. This next problem's a little tricky. It looks harder than it really is. So here, this is an example of a problem from this column called Ask Marilyn. She's supposedly a super genius. People ask her all sorts of questions. And it's told that a certain drug is 95% accurate if the person is a user. Let's write down what this means. So let's take a second and look at this, okay? Let me see if I can do this real quick. Okay. If the person's a user. Oh, let me do this again. Didn't take it. Okay, so what does this mean? This means that if the person's a user, so this goes here, right? The probability that they'll have a positive test result, right? The result is positive 95% of the time. Well, notice this is just a sensitivity, right? This is the probability that if a person has a disease or has the condition, they test positive, okay? So this automatically answers what the sensitivity is. It's just 95%. Notice that this is the specificity down here. If they're not a user, in other words, if we know that they're minus D, okay, there's a 95% probability the test result will come back negative. Okay? So this is just the specificity. Now, if they're not a user, so this is what we know. The if part goes here. This is the given. Right? So if they're not a user, it tells us the probability that they have a negative test result given they're not a user. and that's the specificity, which is given as 95%. So really we don't have to do any work. It's just knowing how to interpret what the specificity and the sensitivity are, and that's actually quite important. Okay, and that's all for the homework problems.